Hey everyone, welcome to the show, where I am trying my best to make my life less miserable. So, to make my life less miserable and clueless, I started hunting for a game dev internship. Well, I finally landed an interview, and it came with a small challenge. They wanted me to code chess piece movement. Just simple chess. You know, that game with like 6 different pieces, each moving in its own wacky way? No big deal, right? No, for me it was a big deal because I never worked on board games. And they gave me a template of the chessboard, and the chessboard was already set up, all the black pieces were there. All I had to do was make them highlight all the possible moves when selected. Sounds easy enough, but trust me, it was a roller coaster. So in this 2-part series, we're going to break down how I tackled this assignment, from basic selecting chess pieces to highlighting the moves that could kill the enemy chess piece. So, let's dive in. So, in their assignment folder, there was a note, and in this note, first they explained what I have to do, and then they gave me a few helper functions like these. And I will show you guys how I use these helper functions in a later video. Okay. Now, first I broke this assignment into many smaller tasks, like selecting chess pieces, identifying them, coding all the possible moves, and finally highlighting the moves. Then I jumped on my Unity editor and opened the project in it. I never made a game that requires selecting game objects by clicking or tapping on them. So, I searched on the web, and I got a function called onMouseDown, but to make it work, it requires a collider, so I gave the colliders to each chess piece. So, I made a script named selectChessPiece and added it to every chess piece. In the script, I used the onMouseDown function, which is called when the user presses the left mouse button while over the chess piece. Inside the function, I used gameObject, named to identify the chess piece that is selected. After doing this, my 2 tasks that I set up were completed. Now, I have to do coding for all the possible moves that a selected chess piece could make. So, after identification of the selected chess piece, I have called their individual movement function. For example, if the selected chess piece is a pawn, the pawn movement function will be called. Now I will show you guys how I coded the moves of all the chess pieces. First is the pawn. We all know the pawn moves 2 squares forward for the first move and 1 square after the first move, and I didn't know that after the first move the pawn moves 1 square, so I have not coded that. And now, I think I am doomed. Anyway, here's the code for pawn movement. I have blocked a few lines of code so that I could explain the code in a systematic way for better understanding. So, here I ran for loops so that I could highlight every square where the pawn could move. ChessPiece.POS script is a variable that stores a script that contains the info of the current position of the selected chess piece, and every chess piece has this script on it. In the chessboard, these are the rows and the columns. So, the pawn can move 2 rows upward from the current row. That's why the for loop is started with the current row +1 and ended at the current row +2. You guys may be wondering why I have added 1 in the start of the loop, because I didn't want to highlight the current cell where the selected pawn is standing. And to highlight the rows, I have used one of the helper functions, highlight. To use the helper function, I have to pass the row and column values that needed to be highlighted, so I have put down the value of I from the for loop and left the column as it is. Now, we know how a rook moves, right? If not, then the rook moves forward, backward, or sideways. So, I had to highlight all the rows in their column for a forward and backward move and all the columns in their row for a sideways move. To do this, first I used a for loop, and in it, the starting value is the current position of the rook in the row +1, and the end of the loop is 7 because there are 8 rows and 8 columns. And the counting starts with 0, so 7 will be the last column or row, and increment the value by 1, and I got a forward move of the rook. Similarly, I have done to calculate the backward move, but in place of incrementation, I decrement the value, and the end value is changed to 0. Now for the sideways move, I just changed the chess piece POS script.row to column and did the same code as for the vertical moves. Now, for the highlighting part, I did the same thing as in pawn movement, just changed the value of row and column in the helper function to the value of I from the for loop. So, after implementation of moves of pawn and rook, now it was time for the bishop. Bishop moves diagonally on chessboard. It can move forward and backward diagonally and side to side diagonally also. So, to code the bishop moves, I divided its move into 4 parts. This code handles the bishop's movement along the top right diagonal. A for loop is used to check each square along this diagonal. The variable I starts at 1, representing 1 square diagonally away from the bishop. In each iteration of the loop, I increases by 1, checking the next square further along the diagonal. The loop continues as long as 2 conditions are met. The new row position and the new column position are both less than 8. This ensures that we stay within the boundaries of the 8x8 chessboard. For each valid square along the diagonal, the highlight function is called. The row and column values passed to this function are calculated by adding I to the bishop's current row and column, effectively highlighting each successive square along the diagonal. The loop stops when it reaches the edge of the board. Now, let's look at the bottom right diagonal. The logic is very similar, but there's a key difference. We're moving down the board, which means the row number decreases. Therefore, in this loop, we check if the new row position is greater than or equal to 0 to stay within the board's boundaries. Also, when calling the highlight function, we now subtract I from the bishop's current row to move down the diagonal, while the column value still increases. The rest of the logic, such as the loop structure and boundaries checking for the column, remains the same. The loop continues until it hits the bottom edge of the board. For the top left diagonal, we're moving up, that is, the row increases, and to the left, that is, the column decreases. So, the loop condition becomes row plus I less than 8 for the top boundary and column minus I greater than or equal to 0 for the left boundary. Accordingly, we call the highlight function, and again, the rest of the logic remains the same. Like this, I have also coded the bottom left diagonal too. Alright folks, that's a wrap for today's coding adventure. We've conquered the bishop's diagonal dance, hopefully without any of us falling off the chessboard. In the next video, we'll tackle the remaining Royal Rumble, the knight, queen, and king. We'll also dive into the exciting world of enemy pieces and finally reveal the secret sauce of how I check if a square is occupied, because, let's be honest, nobody wants to accidentally merge 2 chess pieces into 1 super piece, unless that's a game mode you're into. Until then, keep coding, keep gaming, and may your bugs be few and your coffee strong.